Let's look at another example of a free-falling body problem. A ball is thrown up with an initial velocity of 29.4 meters per second. So let's solve for the following three things. A, how high does the ball go? B, what is the velocity when the ball is 35 meters above the ground? And C, when does the ball hit the ground? Alright, so let's start off with A. How high does the ball go? Okay, so the first thing we need to do is we need to get an equation for the position of this ball. So if you remember our position function, and in this case because it's in meters, we have to use a negative 4.9 t squared plus v sub naught t plus s sub naught. And so the negative 4.9 goes with the meters. Alright, we need two things. One, we need an initial velocity, and the second, we need an initial position. Well, in this case, our initial velocity, it says, with an initial velocity of 29.4 meters per second. Our initial position, well, it doesn't say anything about it being a certain height above the ground. So for this problem, we're just going to have to assume it was 0 meters. So our position function is going to be s of t equals a negative 4.9 t squared plus 29.4 t. Alright, so now that we have our position function, well, the question becomes, how high does the ball go? And so if we were to sketch kind of what's going on here. Now if you look at this equation, this is a parabola, and it's a parabola that's facing down. So this parabola would have some shape like that. And so when we look at the max height, which is right here, we have to think, well, when does that max height occur? And the max height occurs, well, as the ball's going up, it starts slowing down, and at some point, the ball actually has to stop. And granted, it's probably for just a split moment, but it has to stop before it goes the opposite direction. So the ball reaches its max height when the velocity is 0. So let's write that down. The ball is at a maximum height when the velocity is 0. So the velocity, v of t, which is the derivative of the position, is going to be, well, we take a negative 4.9 and multiply it by 2, so that's a negative 9.8 t plus 29.4. So the derivative of t is just 1, and so we have the 1 times 29.4. Okay, so we set this equal to 0, and we solve. It's a negative 9.8. Let's say, so a negative 9.8t equals a negative 29.4, and then we divide each side by, let's see, a negative 29.4 over negative 9.8. So let's see what that ends up being. Grab our calculator. 29.4 divided by 9.8 gives us 3. Alright, so what does that 3 seconds mean? Well, going back to our little drawing over here, our little sketch of our parabola, the 3 seconds, because this is time, and this is position. So the 3 seconds is this. That's when it gets to its maximum height. However, we actually need its maximum height. So to get its maximum height, we've got to take our 3 seconds and put it back into the position function. So S of 3 is going to be a negative 4.9 times 3 squared plus 29.4 times 3. So let's see what that ends up being. So we're going to have, let's see here, 3 squared times a negative 4.9. And then we're going to add on to that 29.4 times 3. And that gives us 44.1 meters. And so there's the answer to part A.